Good day, students! By the way, I am Professor Epifania G. Loreto, the current head of the Department of Civil Engineering. As we all know, the new curriculum for this program, the BS in Civil Engineering, has already started way back in the academic year 2018-2019. Based on CMO 92 series of 2017, all students taking this degree program will now be experiencing to have their own field of specialization, unlike the previous curriculum for BSCE. Now, talking about the fields of specialization, BSCE has 5, namely the Construction Engineering and Management, Geotechnical Engineering, Structural Engineering, Transportation Engineering, and the Water Resources Engineering. For you to know about the background of each specialization, the department has appointed a faculty who will be the coordinator for each field, and each coordinator has prepared a short video discussion. They will be talking about the brief definition of the field, the courses you will be taking if you choose this kind of field, and the possible job opportunities after graduating or after pursuing further studies for your chosen field. Since some of the faculty of the department are now pursuing their graduate studies, only 3 fields of specialization will be open. So I hope that after the video presentation, you will be enlightened about what field will you choose before graduating. Without further ado, let's now watch the videos.
Good day, everyone. Welcome to the orientation on the specialized courses for the incoming 4th year students and for the school year 2021 to 2022. By the way, I am Engineer Ramil B. Vincolado Jr. and I am the coordinator for the Construction Engineering and Management field. To start with, let us first define what is construction engineering and management. Construction engineering and management is a field in CE that uses critical thinking in technical and scientific fields to improve a construction project. This often involves designing and executing new solutions and faster processes that can help overcome worksite obstacles and improve efficiency. Construction engineering and management can help improve safety, productivity, and natural disaster resilience. Any aspect of the construction industry could be addressed by construction engineering and management. So here are the specialized courses under this field. First is the Project Construction and Management, or CENC 151. So prerequisite is your CN 146N, which is the Construction Methods and Project Management. By the way, you cannot take this course the moment that you are not able to finish yet taking CN 146N. Co-requisite is none. Credit is 3 units, which is purely lecture. Semester offered is first semester, and the number of hours. For each lecture, we have 1 hour per lecture, so a total of 3 hours lecture per week. For the course description, this course seeks to introduce the student to the basic theories and tools of management and decision making. It tackles in detail the function of management in managing the following aspects of a corporation: production, service operations, marketing, and finance functions. This course will enable the students to acquire and develop the skills in defining, planning, and monitoring engineering projects using basic engineering management tools and techniques. Course outcomes. So after completing this course, the student must be able to describe the management process and explain the different functions of management, craft a personal mission and vision statement, perform a SWOT analysis, identify the types of organizational structures, identify management practices applied in civil engineering. So basically, this project construction and management is just a further discussion of what was discussed during your ESI 143, which is your engineering management. The next one is your Advanced Construction Methods and Equipment, which is your CNC 152. Prerequisite is still CN 146N, Construction Methods and Project Management. Credit is 3 units purely lecture, offered semester for the first sem, And its description is it deals with the principles of construction methods and equipment management and their applications. It covers analytical techniques for project planning, scheduling, monitoring, and control. It also includes concepts on organization, quality control and assurance, quality management, safety, information systems, and computer applications and software. So students are given opportunities to visit actual sites and observe the application of these theories and concepts in the construction projects. So the course outcomes for this is, after completing this course, the student must be able to, number one, draw a network diagram using the activity on arrow or the AWA and the activity on node or the ION methods. Prepare and update construction estimates, schedule, material, and manpower report, and calculate labor and equipment productivity. Read and interpret construction plans, working drawings, contract documents, and technical specifications in the preparation of a complete bid for a construction project. Identify and present a traditional and new methods, theories, practices applied in construction projects. And the last one is investigate reports and propose a solution to a safety or quality issue in a construction project. So this course is the further expansion of your CN 146N, which is your construction methods and project management. The next one for the second semester, so we have your CENC 153, which is the database management in construction. So still, the prerequisite is CN 146N, the construction methods and project management. Same credits, 3 units purely lecture, second semester, and then that's 3 hours lecture per week. So for the course description, the course covers civil engineering information systems, information engineering and architectures, information strategy, enterprise-wide information strategy planning, case tools, relational database, modeling and normalization, Zachman's framework, object-oriented modeling and design, data warehousing, and data mining. So for the course outcomes, after completing this course, the student must be able to identify project information system, recognize structures and functions of project components, write and present reports in the proper format and in correct English using word processor, spreadsheets, develop teamwork and cooperative learning through group exercises. Model existing information system in construction industry and design and propose a new database management system in an existing information system in the construction industry. The second to the last course is the Construction Occupational Safety and Health, or it is also known as your COSH. So your COSH is still the prerequisite is CN 146N, which is your Construction Methods and Project Management. We have 3 units per lecture for the credit. Second semester is the semester offered for this course, and then 3 hours lecture per week. So for the course description, this is an introductory course on occupational safety and health management that follows a risk management approach based on international standards and best practices by organizations such as the International Labor Organization and the Institution of Occupational Safety and Health. So topics include the relationship of health and safety, identification and control of workplace hazards and risks, and practical workplace assessment with an emphasis to personal safety. Finally, this course focuses on the management principles rather than techniques and methods. So for its course outcomes, after completing this course, the student must be able to, number one, discuss and explain the importance and value of safety, describe the different health and hazards and their preventions, apply the concepts and principles of safety and engineering practice, and explain safety as the engineer's professional and moral responsibility. The last one is your construction cost engineering. This is your CENC 155. Still, the prerequisite for this is your CN 146N, which is your Construction Methods and Project Management. 3 units purely lecture. Semester offered is second semester, and the number of hours is 3 hours lecture per week. For the course description, the course deals primarily with cost engineering and accounting systems in construction projects. Discussion covers data to be collected, information to be produced, procedures and policies in system implementation and typical forms used. Relevant topics in financing and purchasing are also discussed. Computer applications will be considered as well as practical insights on the cost control systems of ongoing construction projects. For the course outcomes, after completing this course, the student must be able to apply the project management information system, cost engineering and accounting concepts in construction projects to analyze and design an improved cost engineering and accounting system for a construction project. So all of those things are your subjects or courses for the field of construction engineering and management. So, what are the possible careers for those students who are taking or specializing the CEM or your construction engineering and management? So, basically, CEM practitioners may work in various construction organizations, so such as we have general contractors, construction management firms, specialty contractors, design builders, consulting engineers, architecture firms, home builders, real estate development firms. So CEM practitioners may be employed also in various positions. So number one, we have project engineers, project managers, coordinators, estimators, schedulers, safety specialists, business development managers. So some rise to senior level executive positions while others own and operate their own firms. So basically, since this specialization deals with construction engineering and also the management, no, so others opted to have or to start their own construction firms. So that is one of the advantages of taking this specialization. So I would like to announce that construction engineering and management will be offered starting the academic year 2021 and 2022. So just keep posted for the announcements and how are you gonna enroll for this specialization. So thank you everyone and God bless.
Okay, so good day everyone. I am John Christian Gaviola, the coordinator for this specialization geotechnical engineering. And I'll going to discuss to you the specialized courses for this track. By the way, the whole BSCE curriculum was designed based on the CHED Memorandum Order number 92 series of 2017 and as per the BOR resolution number 73 series of 2018. So geotechnical engineering has been throughout the years an often overlooked but nonetheless integral part of human endeavors towards progress. Everything around us is supported by soil or rock, no? So, and geotechnical engineering is responsible for that. Anything that is not supported by soil or rock either floats, flies, or falls down. But what is really geotechnical engineering all about? Okay, so let's find out or let's define what is geotechnical engineering. So geotechnical engineering is the science that explains the mechanics of soil and rocks and its application to the development of humankind. It includes, without being limited to, the analysis, design and construction of foundation, slopes, retaining structures, embankments, roadways, tunnels, levees, wharves, landfills, and other systems that are made of or are supported by soil or rock. So the specialization involves using the scientific method and principles of engineering to collect and interpret the physical properties of the ground for use in building and construction. Its practical application, like in foundation engineering, has come to require a scientific approach. So the term geotechniques is currently used to describe both the theoretical and practical application of this discipline. So what are the specialized courses under this CENG, CENG, or the geotechnical specialization? So let's start. Actually, we have the 5 specialized courses. No? So let's start with CENG 151. Okay, so what is CENG 151 all about? So this CENG 151 has a course titled Geotechnical Engineering 2 or Rock Mechanics, which has a prerequisite CENG 136N Geotechnical Engineering 1, Soil Mechanics. So as per its course description, so this course provides an introduction to the theory of rock mechanics and its application in mine construction and operation. Students are presented with the fundamental concepts of stress and strain in isotropic and anisotropic rocks and conduct stress analysis using the data collected in the laboratory and in field. Rock mass structures and classification schemes are introduced, and students learned how these govern rock slope stability and underground rock excavation methods in a given stress environment. So what are the course outcomes for CEng 151 or Technical Engineering 2? So after completing this course, the student must be able to. So we have 7 course outcomes. So number 1, you should be able to identify the objectives of the geotechnical data collection and rock mass classification methods and successfully collect and analyze a range of geotechnical data set for design purposes. Second is, you must be able to describe the theory and analysis of in situ and induced stresses in a rock mass and structurally controlled failure. Number 3 is, you must be able to apply the principles of rock mechanics and excavation design to develop excavation proposals for given geologic environments. You should be able to explain the principles and techniques of reinforcement design for preliminary failure modes in underground rock excavations and apply these principles and techniques to inform design for tunnels and large excavations. You should be able to describe the theory, the analysis, and the control of rock and soil slope stability and rock fall hazards. Calculate the factor of safety of rock slopes and underground excavation. And lastly, the student must be able to describe the mechanical implications of various blast types and patterns for underground excavations. So, first pa lang no, murag heavy na. Okay, so let's move forward to the second specialized course, which is CEng 152 or the Foundation Engineering. So still the same, which has a prerequisite of CEng 136N or the Geotechnical Engineering 1, the Soil Mechanics. So the course title is Foundation Engineering with 3 units credit and offered every first semester of the school year. Okay, so this course reviews the fundamental concept of index and classification properties. So I hope you are already familiar with the index properties of soils, no? Like the plasticity index, the liquidity index, and other index properties. Okay, we have also a review of the water flow concepts, effective stress concepts, the consolidation behavior, the shear strength of soils, which is actually a very important concepts or concept in this topic, no, the foundation engineering. Okay, so subsurface exploration, like its sampling and characterization methods, and reporting of its variability. Okay, so the other topics of this course includes the earth and retaining structures, the shallow foundation design, and the deep foundation design. So we have 6 course outcomes for foundation engineering. So after completing this course, you should be able to, number 1, plan a subsurface exploration and select appropriate drilling, sampling, and field property measurement tools for different soil properties. Okay, So it's all about subsurface exploration, no? So if you say subsurface exploration, that is something beneath, no? Meters below the ground. So that is why we have this drilling, sampling, and other field property measurement tools. Okay, so number 2 is create. You should be able to create an idealized soil profile for analysis and design from collected soil samples. Soil properties. Evaluate laboratory and field data to select appropriate parameters to use in foundation analysis. And then determine the lateral loads from soils. No, the lateral loads. This is actually very important in the foundation engineering na concept, no? So we have this design earth retaining structures, and lastly, you should be able to apply shallow and deep bearing capacity and settlement equations for design with application correction factors with a consideration of water effects and layering. Okay. So that's our second specialized course, Foundation Engineering. So moving forward to the third specialized course of this track, we have here CEng 153, which is Geotechnical Earthquake Engineering. Okay, so the course title is Geotechnical Earthquake Engineering. So still has a prerequisite na CEng 136N, which is Geotechnical Engineering 1 or Soil Mechanics. Okay, so this course on Geotechnical Earthquake Engineering introduces the fundamental concepts of earthquake engineering related to the geotechnical problems, principles of earthquake, wave propagation, dynamic soil properties, liquefaction, and seismic design of various geotechnical structures. This course focuses on the seismic hazard analysis, which includes both the probabilistic and the deterministic hazard analysis, and then followed by site response analysis. Also, behavior of various geotechnical structures such as shallow and deep foundations, retaining structures, low ground anchors, waterfront retaining structures, reinforced soil wall, tailing dam due to the earthquake loading are discussed with reference to codal provisions. So we have 5 course outcomes for this CEng 153 Geotechnical Earthquake Engineering. So after completing this course, you should be able to classify and evaluate earthquake sources or loads, and associated geotechnical earthquake hazards, and then explain key concepts in the seismic assessment of the engineering structures, interpret the behavior of soils and geotechnical structures during earthquake, and apply simplified design-oriented methods for liquefaction analysis and seismic analysis and design of retaining walls, embankments, bridge, and building foundations. And lastly, you should be able to analyze the response of sites, earth structures, and soil structure systems under earthquake loads or other cyclic loading. Okay, so that's these are the course outcomes of CEng 153. So moving forward to the fourth specialized course under geotechnical engineering. So we have here the CEng actually, no, the big letter G, CEng 154, ground improvement. So with the course title, no, CEng, this is wrong, no, this is CEng 154, ground improvement. Still with the same prerequisite CN 136N, Geotechnical Engineering 1, Soil Mechanics. So, as more engineering structures are built, it becomes increasingly difficult to find a site with suitable soil properties. So the properties at many sites must be improved by the use of some forms of soil improvement methods. So the objective of this course is for you to understand the common ground improvement methods, including this densification and compaction. It also includes the preloading consolidation by prefabricated vertical drains, vacuum and electroosmotic consolidation, physical and chemical stabilization, the soil reinforcement, and seepage and dewatering. The focus of the discussion will be on the understanding on scientific principles and appropriate applications, like the degree to which the soil properties may be improved, the advantages and limitations. So case study will be presented as part of the learning process throughout this, throughout the whole course. Okay, so we have 4 course outcomes for ground improvement CM 154. So number 1 is to design. You should be able to design and analyze foundations on difficult soils. Number 2 is design and analyze embankments and earth dams. Third is design and analyze earth retaining structures. And fourth is to develop methodologies for seepage control, dewatering, and other ground improvement projects with consideration of enhancing the benefits and reducing the costs. Okay. So for the last course, a specialized course, we have the CN 155, the foundation and retaining wall design. So we have still the same, no? The prerequisite is just a passing grade of CN 136N or the Geotech 1 Soil Mechanics. So this specialized professional course for civil engineering students in design to understand the concept, the theories and principles in the design process of structural foundations and retaining walls. So after completing this course, the student must be able to, number 1, understand the concepts, principles and theories of structural foundation and retaining wall design, and to demonstrate how to design structural foundations and retaining walls. Okay, so mauna siya ang 5 specialized courses under the geotechnical engineering. If ever these specialization will be offered. So those are the 5 specialized courses, no? As indicated sa atong course curriculum na checklist. So what are the possible careers, no, for the geotechnical engineers? So after completing this degree program, no, you can have your diploma, no, with the title Bachelor of Science in Civil Engineering with the specialization in geotechnical engineering. So that will be indicated in your diploma. So what are the possible careers that you will expect, no? So geotechnical engineers perform functions within the framework of these following jobs. So we have the geotechnical or geological engineer, no, the general geotechnical or geological engineer. So mo yung pinaka very known one, no, the possible career for geotechnical engineers. So these geotechnical or geological engineers provide analysis and mapping of technical results obtained from seismic surveys and investigative subsurface conditions and materials to determine their properties and risk. So how about for the geotechnical engineer for oil sand projects? So what are their functions? So they design open pit walls, the mine waste dumps, and dam structures used in oil sand mining, and analyze slope stability, seepage, and hydraulic separation on dam structures. So you can also, if you want to become a hydrogeological engineer, so what are the functions of this hydrogeological engineer? So they provide design and analysis of pond containing discarded oils and materials, water extraction from soil and sand, and stream injection into wells, and they evaluate underground water layers trapped in rocks or aquifers. So they also provide advice on environmental restoration. So hydrogeological engineer. So next is reservoir geomechanics engineer, and we have also the geomechanics engineer. So same lang na sila, no? But for reservoir geomechanics engineer, no, they analyze the relationship between the physical structures and marine geology, no, anchoring systems, sediment erosion, slope stability, and foundations for offshore and coastal structures, no. So geotechnical engineers, no, are highly demand, no, in offshore and coastal na structural constructions. So geotechnical engineers can be employed by the following types of organizations. So you can work either of the following organizations after completing your course. So colleges and universities. So you can be or you can work in any colleges and universities. Construction contractors, electrical utility companies, engineering consulting firms, and in mining companies, municipal, regional, and federal governments, oil and gas exploration, production, and transportation companies. You are also in demand in petroleum services companies, public and private research organization, and real estate development companies. So this is where you can be employed if you want to take, or if you will be graduating with specialization in geotechnical engineering. So I think that's all for geotechnical engineering field. So specialized courses will be offered soon. And thank you for watching.
Hello everyone, I am Engineer Marcelo T. Abrera Jr. and I am the coordinator of Structural Engineering Specialization, and I will be presenting the specialized courses for structural engineering under the Bachelor of Science in Civil Engineering. Let us first define what a structural engineering is. A structural engineering is a field of civil engineering that deals with the design and analysis of different structures such as buildings, flyovers, bridges, tunnels, towers, etc. In simple ways, structural engineers make sure that the structure should be strong and withstand all the atmospheric conditions. A structural engineer creates drawings and specifications, perform calculations, review the work of other engineers, write reports and evaluations, and observe construction sites. So if you choose the structural engineering track, what will be the specialized courses that you will be taking? First, of course, is the CNS 151, the Computer Software in Structural Analysis. The prerequisite for this subject is the CN 135, that is the Structural Theory. So the credit for this subject is 3 units, 1 unit laboratory, and 2 units lecture. This is offered in the first semester, and the number of hours per week is 5 hours. This is a specialized professional course for civil engineering students in structural engineering aimed at introducing to them the state-of-the-art computer tools in structural analysis that are available in the market. After completing this course, the student must be able to become familiar with the computer software commercially available for structural analysis and knowledgeable in their use and application. Another course that you will be taking is the CNS 152, that is the Earthquake Engineering. The prerequisite for this subject is again the CN 135, the Structural Theory. The credit is 3 units, and this is purely lecture. Okay, this is to be taken on the first semester. The number of hours per week is 3 hours. This is a specialized professional course for civil engineering students in structural engineering designed to understand the theoretical, practical, and computational aspects of the earthquake excitation in relation to structural design. At the end of the course, the students must be able to understand the occurrence and origin of earthquakes, understand the structural dynamics, and appreciate the response of structures to seismic excitation. And then last is apply the latest developments in earthquake and seismic design relevance to the National Structural Code of the Philippines. Another course that you will be taking is the design of steel structures. This is the CNS 153. The prerequisite for this subject is the CN 142N, that is the principles of steel design. The credit is 3 units. This is offered in the second semester of the school year, and the number of hours per week is 3 hours. Design of steel structures is a professional course for civil engineering students and structural engineering designed to enable the design of steel structures. At the end of the course, the students must be able to understand the process involved in the design of steel structures and demonstrate how to design a steel frame structures such as a building or transmission tower. Another subject that you will be taking is the reinforced concrete design, that is the CNS 154. The CNS 154 has a prerequisite which is the CN 144N, that is the principles of reinforced or pre-stressed concrete. And then the credits for this subject is 3 units, and this is purely lecture. This is offered in the second semester of the school year and 3 hours lecture per week. This subject is a specialized professional course for civil engineering students in structural engineering designed to enable the design of reinforced concrete structures. At the end of the course, the students must be able to understand the process involved in the design of reinforced concrete frame structures and demonstrate how to design a reinforced concrete structure such as a building. The fifth course that you will be taking is the bridge engineering, that is the CNS 155. So this course has 2 prerequisite subjects. They are the CN 142N, that is the principle of steel design, and CN 144N, that is the principles of reinforced or pre-stressed concrete. This is 3 units and purely lecture. This is offered in the second semester of the school year, and 3 hours lecture is needed per week. This course is a specialized professional course for civil engineering students in structural engineering designed to understand the concepts, theories, and principles in the design process of bridge structures. At the end of the course, the students must be able to understand the concepts, principles, and theories of bridge design, demonstrate how to design a simple span reinforced concrete deck girder, and steel truss through bridge. When you choose structural engineering major, some possible careers you may want to become in the future are structural designer, someone who designs structural plans, project manager, so usually structural engineers are very good project managers, contract engineer, okay, consultant, and you may want to become a forensic structural engineer. Actually, guys, when you choose the structural engineering major, there are still more specific specializations you may want to focus in the future, such as the wind engineering, fire engineering, and earthquake engineering. And there are still many other more specializations under the structural engineering. So what are you waiting for? Choose structural engineering track now. Structural engineering will be offered starting academic year 2021 to 2022. Thank you everyone for watching, and God bless.
Hello students, before anything else, I would like to congratulate each of you for making your way up to this point. So from this moment, bear with me as I, Ma'am Lindy, will be your guide for this tour in transportation engineering. So, welcome aboard. What is transportation engineering? So, transportation engineering is a sub-discipline of civil engineering in which it involves planning, design, construction, operation, and maintenance of transportation systems. So, this system may refer to our roadway system, waterway system, railway system, and of course our airway system. So, it has a goal to provide the safe, comfortable, convenient, economical, and environmentally compatible transport of people and goods. The Department of Civil Engineering of Visayas State University offers 5 specialized courses for transportation engineering. So the first 2 are offered every first semester, and the remaining 3 courses are offered every second semester. The first course we have here is CNT 151, which refers to Transportation Systems Planning and Design. Its prerequisite is CN 141N, the Principles of Transportation Engineering. It has a 3-unit credit, which is equivalent to 3 hours lecture per week. So the course gives emphasis on the transportation sector of the economy, its function, players, technologies, policies, and its information sources. It also discussed about planning and analysis tools of transportation demand and investment, the role of high technology in transportation, and the current high-profile transportation policy and planning issues. So after completing this course, the student must be able to first describe the elements of transportation, evolution of urban transportation and its policy, explain the modeling transportation systems, urban travel and transportation system characteristics, and travel demand with land use, and lastly, to make a modeling of mode choice and traffic assignment. So second course, we have CNT 152, which is Highway Engineering. Its prerequisite is ESI 121N, the Fundamentals of Surveying. So it has 3-unit credit, which is equivalent to 3 hours lecture per week. So in this course, it will deal with the development of highways and the Philippines, highway design, and the materials that are used in road construction and maintenance. It also discussed about the standard specification for public works and highways, and that's it. So after completing this course, the student must be able to discuss the development of early roads and highway and the Philippines from the early part of 1900s to the present era, to recognize the importance of planning stage of a proposed road construction project and be familiar with the items conforming to highway design standards, apply the methods of analysis and design relevant to highway engineering, and to define the factors that affect the performance of highways and related structures. Next, we have CNT 153, which is the airport design. So its prerequisite is Principles of Transportation Engineering. Again, it has 3-unit credit, which is equivalent to 3 hours lecture per week. So in this course, it will give emphasis on the air transportation, history, and airport planning. So it will also discuss the aeronautical requirements for airport design, airside operations, so navigation and air traffic control, airport terminal level of service standards, simulation modeling of passenger terminals and airport security issues, air traffic flow management, and environmental impact. So by the end of this course, the student must be able to state the history of aviation and requirements of airport design, explain the runway length, airspace requirements, navigation and traffic control, illustrate airfield capacity and delay, runway and taxiway geometrics, and passenger terminal capacity. And lastly, to explain the air traffic flow management, airport management and economics, and airport noise. So we have CNT 154, so this is the ports and harbor. Its prerequisite is CN 141N and also CN 138N, which is the hydrology. So it has a unit of 3, which is also equivalent to 3 hours of lecture. So in this course, it will give emphasis on the planning, development, design, construction, and operation of ports and harbors as modes of transportation. It also gives a thorough discussion of the types and classification of ports and harbors, theory and principle of oceanographic survey, so which refers to tides, currents, and waves, ports and harbors planning and development, hydraulics of river and its improvements and controls. So after this course, the student must be able to show familiarity in the concept and importance of port operation in the economic development of a nation, to knowledgeably plan ports and harbors and discuss the developments and operation of ports and harbors, and also to investigate and analyze areas of improvement in ports and harbors. Okay. Lastly, we have here the mass transit engineering, or your it discusses thoroughly the public transportation system. So its prerequisite is CN 141N, the principles of transportation engineering. It has a unit of 3, which is again equivalent to 3 hours of lecture per week. So this course give emphasis on the planning and design of public transport facilities and road and rail-based transportation. So after completing this course, the student must be able to first learn the fundamental concepts of transit planning and design, acquire an overview of road and rail-based transportation, understand the evolution and role of urban public transportation modes, systems and services, focusing on bus and rail, and explain the technological characteristics of mass transit systems along with their impacts on capacity, service quality, and cost, and to learn the current practice and new methods for data analysis, performance monitoring, route and network design, frequency determination, and vehicle scheduling of mass transit systems. Possible careers. So of course, we have transportation engineer, as highway engineer, airport engineer, and port engineer. So you can choose in this place where you can have your career path. So you can have in education. So of course, as an educator of future civil engineers, you can also work in the government. So we have the Department of Transportation and its sectorial offices or attached agencies, or you can have your career in any consultancy and construction firm. So that ends our orientation for the field of transportation engineering. So thank you for watching.
Good day, everyone. I am Engineer Gladys G. De Dora, your WRE coordinator for the department. So for today, we are going to have an overview on the orientation on the specialized courses for water resources engineering offered this academic year 2021-22 for the new curriculum. So what is water resources engineering? It is a branch of civil engineering which is focused on the preservation of Earth's water. It is the study and management of equipment, facilities, and techniques in water resources, and the sustainable use of water resources by conserving water, assessing and controlling water, waste disposal and canal development, building of dams, irrigation systems, planning and management of available water supply. It also involves water treatment processes, improving the quality of water for various end uses, ensuring safety, favorable conditions. So we have here the specialized courses of Water Resources Engineering, or CNW. So CNW 151, or Water Resources Engineering, has the prerequisite courses of CN138N Hydrology and CN137 Hydraulics. So you can enroll in this subject if you already passed the prerequisite courses. So we have 3 units credit for this one. This is purely lecture, and the course is offered this first semester. So this course covers technical and scientific basis for the design of water supply systems and the design of drainage with depth and thoroughness. The course deals on the following topics. We have flow in closed conduits, design of water distribution systems, rainfall runoff relation, flow frequency analysis, and design of drainage system. So the course will expose the students in getting data from different institutions or agencies and in designing simple water supply system or basic drainage systems that could be implemented in actual work. So after completing this course, student must be able to do an estimate of peak runoff, determine appropriate pump rating to deliver water, for example, in a receiving tank or reservoir, determine the size of a pipe for a given flow rate. We can also have the determination of the parameters of different probability distributions commonly used in flood frequency analysis, and the student must design a basic drainage system and or simple water supply system. We also have CNW 152, and the course title for this subject is Water Supply Planning and Development. The prerequisite for this course is hydrology and hydraulics. There's no prerequisite course for this one, and purely lecture having 3 credit units. So we have the course description for water supply planning and development. This course deals on water uses and the corresponding quality, estimation of water demand, identification of water sources, possible treatment, and development. So after completing this course, the student must be able to identify different water sources and discuss the different treatments needed to comply with the standards for water use, discuss the environmental impacts of developing the different water sources, estimate water demands for different users, and provide typical layout of water supply system. CNW 152 is offered first semester of the academic year 2021-2022 together with CNW 151. We have next Irrigation Engineering, CNW 153. The prerequisite courses for this course are hydrology and hydraulics. So again, you need to pass these 2 courses so that you can enroll Irrigation Engineering. There is no prerequisite course for this one. Purely lecture of 3 credit units. And this is now offered second semester of the academic year 2021-2022. So the course covers soil-water relation, different techniques of irrigation methods, and various technologies, estimation of consumptive use, conveyance of irrigation water, drainage of excess water, sizing of conveyance structure. So more or less, this subject will be an advanced application of the treatment, the process rather of the evapotranspiration or consumptive use that you have in your hydrology. So after completing this course, the student must be able to discuss soil-water relation, enumerate and discuss methods of measuring soil moisture, enumerate and discuss the different types of irrigation systems, perform calculations related to movement of water into the soil, perform calculations to determine the size of irrigation canals or pipes, and to have an estimate of the consumptive use of water using evaporation and evapotranspiration formulas. We also have CNW154 or flood control drainage design. So the prerequisite for this course are the following courses. We have hydrology and the CNW151 or water resources engineering. So we have 3 credit units for this course, purely lecture. And the core deals on rainwater harvesting, storm runoff utilization for water supply, water infiltration into the soil, road drainage, sizing of inlets and culverts, design of detention and retention ponds, flood models, floodgates, and pumping stations. So after completing this course, the student must be able to identify and discuss the different components of rainwater harvesting system, identify and discuss the different components of a stormwater drainage system, identify and discuss the different components of floodgates and pumping systems, and of course, perform calculations related to the sizing of gutters, inlets, culverts, and channels needed to convey stormwater, as well as sizing of retention and detention ponds. And lastly, we have CNW151 or the groundwater flow modeling course. The prerequisite subjects for this are the following. We have CN137 hydraulics and ESI 118 or the numerical solutions to engineering problems. There is no co-requisite for the course, purely lecture having 3 credit units, and the core deals on the different types of aquifers and applications of Darcy's law to formulate water movement through aquifers. The course also covers contamination of groundwater and transport of contaminants and basic groundwater flow modeling software. So after completing this course, the student must be able to discuss the different type of aquifers and the law of Dorsey and its limitation, the formulation of groundwater flow equations for the different types of aquifers, perform calculations related to groundwater movement, like the velocity, the flow rate, or the discharge, and the piezometric levels, and perform groundwater flow modeling using available groundwater flow software. So CNW153, CNW154, and CNW155 are courses to be offered on the second semester of the academic year 2021-2022. So we have here the possible careers on a water resource engineers, or those who are expert in the field of water resources engineering. So water resource engineers can be employed both in government or private agencies, and the following are the tasks that may be assigned to the WRE. So we have first, conduct researches in hydrology and water resources, conduct hydrologic and or hydraulic analysis to collect data and assess sites, write reports and correspondence including tracking costs and schedules, design, amend, and update plans and drawings according to collected data, facilitate project management and communication across team members, and of course we can do modeling, design, and map proposed and current sites and projects. So that is just the possible task that may be assigned for you in the future if you want to become a water resource engineer. So, for those students who are interested in water resources engineering, I am glad to announce it to you that the specialization on water resources engineering will be offered starting academic year 2021-2022. So just keep posted for further details on the qualifications or inquiries with regards to the enrollment in this field of specialization. So that's it. That's the end of my orientation on water resources engineering. And again, we will be glad to have you in this field of specialization. Thank you for watching and God bless. Keep safe always.